Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Muntakim. I'm editor of Robotics and Automation News.com. In this interview, I speak to Mike McCormack, President and CEO of CP Technologies, a manufacturer of ruggedized computers for military and industrial applications.
Yeah, I'm Mike McCormack. I'm President and CEO of CP Technologies. We're based in San Diego, California, and we design and manufacture custom and standard ruggedized computer hardware.
Now, on our website, we tend to concentrate on commercial or industrial applications, but I do appreciate that your company supplies military and industrial applications. I'll just ask one question relating to the military aspect of it. Is there things that you learn or develop for the military that helps you improve or differentiate your products when it comes to supplying them to the industrial sector?
Most definitely. First of all is survivability. So whether you're looking at factory automation or you might be in an oil and gas or mining environment, the levels of ruggedization, a commercial computer may not survive that, or displays may not survive that. Just through heavy usage in a factory environment or robotics, or if you're looking at something that may be used in an industrial mining or oil and gas exploration, obviously the utilization of that in the environment from a dirt, dust, temperature requires a level of survivability that commercial computers don't really come built with. And then military really helped us in the development of that. Besides that is the revision or configuration management and road mapping of products. Many people, obviously in the commercial environment, if you're a Dell or an HP, you build a computer, but you're retooling every 3 to 6 months. A lot of people in the automation or industrial marketplace, those changes mean changes in software, rewriting software and coding to make sure that their system is adapted to the changes that continuously take place in those commercial computer systems. With ours, we have them roadmap and long life components so that we can keep the system consistent in its configuration and its revision for anywhere up to 15 years. And if you're a software engineer or if you understand software engineering, that's something they dream about because it means they're not having to rewrite code or rewrite their software every time that a revision takes place in the hardware. So that's kind of the benefits that come out of the development from the military that has really crossed over into the industrial marketplace, which we've been supporting for the better part of 20 years.
Right, and I can see on your website the type of computers that you supply. You've got a laptop and a server type of device, and what looks like a conventional sort of computer, which can be placed on a desktop. But would you like to just sort of give us an overview or some highlights of some of the products that you supply or manufacture? And then afterwards we can get into some of the components or reasons why they are called ruggedized.
Yeah, we go from tablets, from a 7-inch tablets. We also obviously do all the human interface, so zero clients or thin clients, up to desktop servers, what I call embedded PCs, which are totally sealed systems that are rated IP65, 68. We also manufacture the displays, keyboards, storage arrays, and we run into switches and modems, but on a lesser scale. So really everything within the computer hardware environment, with the exception of laptops. We really don't do the laptops. So The tablet type products that you see on our website are zero or thin clients, which are really dumb terminals, but are cyber secure.
And what is it that makes these ruggedized? What is the difference between a rugged computer and a computer that an average person would have on their desk?
Well, an average computer has obviously a lot of plastic components, front panel, sometimes portions of the chassis, non-locking connectors. The boards aren't conformally coded. So what we're doing is we're taking standard commercial grade products. So we're using, boards like Fujitsu boards, Supermicro, and we're ruggedizing and those conformally coating the boards. And the benefit of this is that you're not doing a custom componentry that can raise the price. You're taking what we call standard COTS, commercial off-the-shelf components, ruggedizing them in a survivable chassis. So you're shock mounting the drives, boards. We put a proprietary thermal management system in as well, so that it focuses on hot spots on the system to reduce, or shall I say, increase the mean time between failure and reduce failures within the system by reducing temperature, reducing the power consumption of keeping fans running continuously, and also minimizing the noise for high power processors that you may have from having to cool them with high-speed fans. So there's several factors, from the ruggedization of the chassis, the shock mounting of boards, locking connectors, conformally coating the boards, and then really the interfacing of the different type of COTS components into a system that is completely survivable and really the harsh environments you can go into. We really focus on everything with the exception of space applications where there's really not a lot of volume there. So.
And what about the performance of these rugged computers in terms of that the average person can understand RAM and speed and things like that? What can you say about some of them?
Well, from a processing, whatever, we're an Intel Platinum partner, so whatever is out there in the Intel world as far as processing power, we can do that. We do a lot of hypervisor systems or virtual systems that are, utilized for high performance computing, HPC, and also high levels of storage capability. We do 200 to 300 terabyte storage arrays as well to really support anything in that computing environment. We have a lot of systems that are expandable, that are transportable. Out in the oil and gas industry, we use a lot of these that go into transit case, but they need the ability to transmit that data through, data links, which we can support as well. So, it really comes down to we work with a customer in a consultative approach, really trying to find out what they're trying to do and we focus on speed, power, and how small of a footprint do they want? Because that's what we focus on is, faster, smaller, less power consumption to give them the maximum amount of processing capability that they need and human interface.
And in terms of designing and manufacturing these products, can you give us an insight into how you go about doing that? Where is the design done? Where is the manufacturing done? Or anything that you can sort of tell us that?
Yeah, all our design and manufacturing is done in San Diego. Like I said, what we do is we work on a consultative approach. We provide we work with the customer with what we call a technical resource document to truly understand 100% of the application the customer is trying to support. We're always acutely aware that cost is a driving factor. So we try to understand the price points that the customer is at and where they want to be at when we're designing a configuration for them. And what we're trying to do is guide them into a situation where we get a lot of people come to and go, hey, I want all of this, but I need it in the smallest package. And we always talk to them about physics and packaging. It goes back to the old adage of how many pounds you can get into a 1 pound bag. And so we take a very consultative approach on processor, what they require, storage, what type of human interface they want, everything from the displays, do they need touchscreen? Do they need direct sunlight readable? What's the environment it's going to go on from a temperature, so that we can make sure that the product is going to have optimum performance in the environment they're going to put it into. And we do all of that, like I said, in San Diego, California.
And it sounds to me like you custom build solutions for specific clients. But I was wondering if there are product lines and maybe components or something that is proving more popular or sells better or anything like that. Any type of maybe a modular system or a ready-made product that sells better, or is every client different and every solution that you supply different?
Everyone is different. So we call it in-house. We call it MOTS, modified off the shelf. We literally have hundreds of thousands of variations of our products. And what we try to do, instead of reinventing the wheel, we're taking ideas that we've done from previous applications and modifying those, as we call modified off the shelf, modifying to meet 100% of the customer specification. So again, it's a little bit picking the different components that the customer may require to meet their performance criteria, but putting it maybe in a pre-existing package that we've already done for other customers. And these can be quite unique. I mean, we're creating, embedded PC systems that are in a totally sealed, 70C environment. They're going to go on in autonomous vehicles, for transportation. We're putting these into, UAVs that are being used by chemical companies for surveying things like refineries. So the applications can be numerous, and some of those, like I said, can be harsh chemical environments like a refinery. It may be something in an autonomous vehicle. Others is robotics. And with each of these, I think, having the amount of years of experience we have, of 23 years experience in developing these, it means that we can take a lot of pre-existing ideas that have already been supported out there and really configure it to meet the customer's requirement.
I'm looking at your website, and I clicked on the industrial computers and servers section, and I don't really know that, I'm not an expert in these things, but they all look like servers to me, all the computers that are listed.
Yeah, they are. So, but at the same time, our website is going through a major update. And if you look at portable systems, you'll see differences in the portables, and they can be used for industrial. They're used a lot for industrial, especially in refinery and oil and gas, where they want to be able to take a computer out to a remote site. So if you look at our portables, you'll see some there. A lot of them are servers or computers that are used in rack applications, or they're used in transit cases. So whether you're using robotics, you may have what they call mini racks. They may be a small rack that sits in the back of a robotic controller, and that robotic controller has a small depth, and we can do something down to 15 inches in some of these applications. So the chassis becomes very custom for their application or an existing chassis design. So not everything we do that you see there will be a rack server. Some of them will be desktops. We do stuff for golf simulators. One of our biggest customers, in the commercial world is Full Swing. And I don't know if you ever heard Full Swing, but they do golf simulators for a lot of the PGA professional golfers. And those are all computers that are standard desktop, but they have very, very powerful graphics accelerators and the capability of they need to be maintained with the same design for years, simply because the amount of software that has to be developed for the graphics applications. So, a lot of our systems aren't necessarily shown on there, but you will probably in the next month to 6 weeks, you'll be seeing massive amounts of updates, because it's sometimes difficult to get everything on there, and because of the number of applications that we support. But we do biosciences. We divide our market in commercial, industrial, military, and the commercial industrial takes up 50% of that, and those go into biosciences, forensics, then also things like simulators, both for commercial applications and industrial. And then it'll also go into other applications like a laser etching, for chip manufacturing, high-end photographic analysis of things like manufacturing, robotics. I could just keep going on and on about the different applications that go into.
Yeah, I'd like you to actually expand on the robotics and automation part. But before I do that, I always forget what a thin client is. I keep thinking I understand, and after a while, I forget what it is. What is a thin client?
So a thin client, or let's talk about a zero client first of all. So you remember back in the days of centralized mainframe computers and the WISE terminals, of the dumb terminals, that you could only access the mainframe. You couldn't really download anything off your terminal. You're just viewing. Well, a zero thin client is doing the same thing. What it does is, and one reason people like them is they're cyber secure. They're power over Ethernet, so they get all their power just over the Ethernet. So once you unplug it, it's wiped. There's no memory where somebody can inadvertently download or take data off the server. They can only view. So it's really just a read tool. So it's really reverting back to that. And so a lot of industrial, we sell both to industrial and also military, where they want cybersecurity, where people can't put a thumb drive into it. They can't download information out of there. They can only read off what's off the server. That's what a thin zero client is.
Thanks for that. Just before we get onto robotics and automation and industry in general, I know you sort of mentioned a couple of numbers. 50% of your business is in the commercial industrial sector, but are there any other numbers that you can share with us about in terms of maybe sectors that you supply? Are they broken down into further subdivided within the commercial industrial space, or any sort of turnover?
Yeah, most definitely. I mean, when you look at the size of this kind of marketplace, the rugged, in the U.S. alone, it's probably running into close to $1 billion. And then the human interface side of it, especially getting into the industrial, less commercial side, you're probably getting into a marketplace that's over $1 billion, probably $1 to $2 billion in human interface. And when you look at the markets that those can be serviced in, you look at everything from biosciences, look at automation, robotics. These are marketplaces that are in the billions of dollars. So there's a very large marketplace for our products to go into. And some of those are not necessarily that we can service, because they all find that it's acceptable to use a commercial grade computer in there. And so we're not actually after that marketplace. We're in the market where they need revision control, configuration management in a commercial product, because that's what we support for the commercial market. So it's a commercial grade computer, but it's revision controlled and configuration managed, which the Dells, the HPs of the world don't do. Then we have the full ruggedized systems that are designed for more robust applications in the oil and the gas, autonomous vehicles, automation, factory automation, refineries, etc., mining.
It's probably difficult for you to answer this because each solution that you supply might be different. But I imagine that your equipment is more expensive than non-ruggedized equipment. It must be. But in terms of percentages, can you say how much more expensive it is?
Well, so if you look at a purely one of our systems that's commercial grade, that is just revision and configuration managed, you're probably looking at a 20 to 25% increase in price. A ruggedized versus a non-ruggedized, you're probably looking at 40 to 50% increase over a commercial grade system.
Right. And let's get onto this robotics and automation aspect of it, or industry in general. What is your experience, and can you give us more insight into what you've already mentioned, that you do work in some robotics sectors? Can you expand on that, please?
Mm-hmm. Well, you know, the one benefit is obviously robotics and automation is increasing significantly. Again, whether it be factory automation and using robots in assembly, or you're looking at applications where you're using automation or autonomous applications, there's enormous growth in those marketplaces right now. Now, strictly speaking of the industrial autonomous, there's a lot in the vehicle market. People are talking about autonomous transport vehicles, trains. All of those are harsh environments that require certain levels of ruggedization and survivability. Obviously, if you have a computer that's sitting in an autonomous truck running up and down roads, it's got to have a shock and vibe. It needs to be able to meet in the U.S. Department of Trade standards. It's got to have a lot of powerful processing, and it has to have a lot of redundancy in the event of failures. So there, you know, especially in the autonomous vehicle marketplace, not necessarily, you know, your car, but in transport vehicles, that is growing significantly. And we've already developed products that are being used by a few companies that I can't name yet because they're in development, that are growing exponentially, you know, in the marketplace. And the same thing would be for factory automation. You know, everybody in the world is concerned about the loss of, you know, the human factor, loss of jobs, but it's also significantly increasing opportunities for companies like ourselves who are building the computers for those type of automation robotics that's required. And even the UAV market, you know, drone market, it's not just a military marketplace. There's a lot used in energy, disaster recovery, you know, border security, and applications outside. And all of those require ground control stations, which we build, that have computer and human interface devices that require levels of ruggedization and revision control. So from our perspective, it's a very bull market. You know, it's a very positive. We see double-digit growth in almost all those type of markets, and I see this continuing to grow for, you know, my foreseeable future.
It's tempting to ask you a number of questions that might be outside of your area, but it's always good to meet someone who's an expert in this field. It's tempting to ask them for them to speculate. But I've heard of new chips that are specially designed to handle artificial intelligence. And some of the things that we're talking about, like the autonomous cars or just cars in general that have advanced driver assistance systems, for example, they're very complex machines nowadays, cars. They're not mechanical anymore, obviously. It went a long time ago.
No.
And artificial intelligence is playing an increasing role in their operation. Obviously, you can talk about drones and other things as well, where artificial intelligence comes into play. But let's start with I don't know how much you can say about
maybe a little bit. I mean, I think the biggest thing is machine learning, you know, and when they talk about machine learning, it's not just artificial intelligence. The machine has to learn and evolve from its environment that you are utilizing it for. So if you're looking at a vehicle, that vehicle needs to take multiple inputs. It's not just monitoring its own engine performance and energy consumption and you know, the wear and tear of the vehicle. It has to be aware of its entire environment. So, you know, the biggest buzzword you hear these days, it's not artificial intelligence, it's machine learning. The machine must learn and evolve its intelligence as it's used in its application. And that's probably the biggest thing that we look at. It's the ability of having a computer that is smart enough to be able to evolve itself in its operation. And that's something that we constantly look at in the development of our products, is how do we make our products smarter and survivable at the same time.
You're obviously a really good person to ask about the next issue, which is the idea of autonomous. I don't want to, as I say, our website doesn't really deal with military things because it's a completely different sort of mindset and tone that we'd have to adopt in our coverage. But the idea of machines becoming autonomous, war machines, for example, drones or any kind of machines that, the phrase killer robots is sometimes used. The idea of artificially intelligent autonomous machines that are not really directly controlled and are not.
No, and that's the you'll hear in the military, red on blue, and identifying. The one thing that we're working on that is the ability to work in an augmented reality. Whether you look at military or industrial, we are in the middle of developing what we call our PAC system, and this is the PAC is literally going to be a network that goes in a pack that goes out in the field, where you can now create a situation. And I come from a military background, so maybe it'll make sense. Imagine a squad of 8 or 9 guys out in the field, and they now have augmented reality headsets, and they have drones flying above them. And the guy now has a network that's on his back where he can communicate and see all of the friendlies around him, but at the same time, he's seeing what the drone sees from 5,000 feet, so he can see all the bad guys at the same time. So it's allowing these guys to work in an augmented reality where they can see their adversaries no matter the geographics or the physical barriers that are around them. They now have a 360-degree view of their adversaries. They are seeing this on their headsets. They're also being able to transmit that data to the rest of the guys in their squad. And that gives, them the capability. But if you think of taking that now out to a situation where you're using, autonomous vehicles underwater, or maybe you're working in nuclear power stations and you need autonomy there, or you need to go out in the field and you have somebody with a backpack on who's being able to work in that environment. All this technology and augmented reality is providing people the ability to do much more than just sitting there looking at a tablet. And I think everybody's going to see as they go along, and probably more in the next generation than my generation, augmented reality will be much more. And that's one thing they always say, they say about the younger generation. They're going to be more suited to this, the gamers are especially, in working in those augmented reality environments.
Yeah, you're talking about things that are happening now, and they seem, I don't know, I don't want to make any judgments, but they seem fairly conventional, fairly within the realms of what most of us understand about the military, i.e., meaning it's not like the Terminator scenario. I hate to use a cliche, but, I'm not very original, but, the first Terminator film, and generally the whole idea of machines becoming completely autonomous and turning on, you don't have to go that far as to say it's turning on the humans, but I can't see, I just think it's inevitable that autonomous machines are going to fight wars without, human involvement in the future. And I don't know how long it's going to be, but probably 10, 20 years, as close as that, really. What do you think?
Yeah, maybe our soldiers will probably be all sitting behind consoles, using their robotics, the robots in their aircraft to fight a war. There'll probably be less, human involvement in direct combat anymore, simply because of, the autonomy of whether it be out in the mountains somewhere, or it be up in the air, or it be on the, you've seen it all the time. They're already autonomous Navy ships. They're already autonomous aircraft. You're seeing people out there building, these four-legged robots that can run around in any environment. The challenge they have is energy. How do you keep something out there in a combat environment for days on end and power it? That's, and that's a totally different discussion. And that's the challenges of technology, of how do you keep the autonomous vehicle out there for, especially in combat environments, for days at a time.
Yeah, well, you're still thinking of the human component. I'm thinking is entirely autonomous, beyond just sort of putting it into operation. The human doesn't really have much involvement thereafter. I mean, that's what I'm talking about. But as I say, I try to avoid military robotics and automation in general. I just wanted to ask you about standards for ruggedization. Are there any sort of recognized standards? What is classified as ruggedized? I mean, somebody could just build a very sturdy.
Yeah, you have, so you have the IP standards, ingress protection standards that are out there. There's electrical standards that are required. You have CE certifications that are required, and obviously UL for the U.S. market, that just to meet the basics. But the biggest one that runs in industrial is there's standards for in explosive environments. I don't recall the name of the specification right off the top of my head, where you might be in oil and gas or refineries. There's requirements there. There's also IP, which is the ingress protection, and there's a European norm for it as well that I can't cross my head, but that allows how much dust and dirt to get into it, or how much moisture it can take, whether it can take a direct shower or pouring rain on it. So there is different standards for industrialization. But right now for the industrial markets, they have a tendency to be more regionalized. So there's certain ones for the U.S. market, there's certain ones for European market, et cetera.
And where are your markets generally? I imagine it's mostly US.
We're pretty much global. I mean, the US probably still makes up 60% of our market, but we have a considerable amount in Europe, also in Asia. We're building out some networks, communication networks out in Thailand right now. So we're very much a global company as far as who we service and support.
And is it a private company, or is it stock listed?
No, we're part of a much bigger organization that builds UAVs, but we're a separate arm of them. So we're owned by Cardinal Integrated Solutions in the U.S., which is our holding company. But currently, it's part of a larger publicly traded company.
Right. And what percentage of your operation, this CP Technologies, what percentage of the overall business do you think it represents in terms of revenue generation, perhaps, or in some other way?
Sorry, I didn't quite get your question. Say that again.
The overall company, the parent company, as a proportion of the parent company's business.
Oh, of us? Oh, of our parent company's business, we're probably about 20% of the parent company's business.
Right. And how long have you been with the company, and what's your background?
4 years. So my background is I'm a former Air Force, U.S. Air Force. Then I've worked in Europe, Middle East, and Africa in both the energy business, also in automation and power electronics and technology market, computing and networks.
Right. And what do you think the future is going to be for you in the next, I mean, I'm not talking distant future, but in the next year or two, do you have plans to do something different for the industrial space or commercial space, new products perhaps, and what is it that, and you can say to an industrial company or a sector, why should they invest in rugged computing? The kind of environments you're talking about, oil and gas exploration and all that, it necessitates ruggedization. But there are probably other sectors that maybe don't need as much ruggedization. I mean, what are the benefits? What are the, or would you not try and sell to them?
really, it's survivability. You know, our product comes with a 5-year warranty. No computer manufacturer provides a 5-year warranty. Second of all, it's revision and configuration management. So if you want a computer that's going to be designed out there, that's going to be able to be utilized for the, you know, from 3 years to 15 years, we develop products where the configuration and the revision of that product will be maintained for the life of that program. So if they have long life programs where they don't want to worry about, you know, standard commercial product changing every 3 to 6 months, that's our value. And that, you know, and that value is, you know, expanding rapidly in the marketplace because people, the cost of changing software and upgrading software with the hardware changes that happen with a standard commercial product can be very costly. So that's where people see our value. It's really maintaining that long life configuration for programs that have high complexity.
Right. Okay. Thank you very, very much for your time and your insights.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.